So one thing I was always told when I told somebody I was preparing for my board exams was that, oh, you should totally go and look at the old question papers. And that was all fun, but it brought on a lot of exam stress that I had been holding in, and that was not great. So I decided to start a video series where we discuss previous year's papers, and this is the first video for that series, and we're going to be discussing the sample question paper for this year, and we're specifically focusing on the section A questions. First of all, before I start, basically you're going to have the questions over here. The solutions are right here. These are the marking. This is the marking scheme given to you by CBSE. And what I've done is I've taken the particular parts of your textbook that have the answer to these questions. So this is also going to help you know where to look for when you're where this answer came from, basically, because most places you can see people give you the reason, people give you everything like that, but no one actually points out to where it is in your textbook. And I think that is a really important thing to know. So we're going to start with section A, and we're going to just do that for this video. So it consists of 16 multiple choice questions, and each one carries 1 mark, and there is no internal choice. Remember, there is no internal choice, and you might want to just think about the answer a little extra when you're answering these questions, just because the way the options are written can sometimes be misleading. So the first question is a monolysis of ethyl chloride followed by the reaction of the amine so formed with 1 mole of methyl chloride gives an amine that. So basically, let's write this reaction. This reaction is already mentioned over here. It's the monolysis reaction of chloroethane or ethyl chloride, and it forms CH3, CH2, NH2, and then this on reaction with another mole of methyl chloride, it gives us a secondary amine. So the question over here is about a particular reaction called the Hinsberg reaction. So, or the Hinsberg reagent. So Hinsberg reagent is a benzyl sulfonyl chloride. When it reacts with a primary, secondary, and tertiary amine, or it actually doesn't react with the tertiary amine, but basically when it reacts with a primary amine, it forms a product which is soluble in alkali, whereas for secondary amine, it does not contain any hydrogen atom, so this is not acidic, so this is insoluble in alkali. And tertiary amines do not react with the benzene sulfonyl chloride. Okay, all of this is from the chapter amines. Okay, now and specifically it's the reaction of amines, and the monolysis, obviously amines. So the first one is reacts with Hinsberg to form the soluble alkali, salt which is soluble. It's true for primary amines, but the product that we have gotten is a secondary amine. The second option, it reacts with, we're going to come back to that in just a second. The third option is obviously the right one as it is given in your marking sheet, but basically it's because it's insoluble in alkali, and that's what's mentioned over here. And the last one is does not react with a Hinsberg reagent. That's a tertiary amine. Tertiary amines do not react with the Hinsberg reagent. So but the product that we've gotten is a secondary amine, so that's not the answer as well. So the answer is option 3. Now, on reaction with nitrous acid, it produces, on reaction with nitrous acid, it produces nitrogen. That is true only for the primary aliphatic amines, but the product that we've gotten is a secondary amine, but for primary amines, you get the nitrogen gas, and because of that, the second option is also incorrect. Okay, now the next question is, which of the following has the highest dipole? Now, based on these options, it's quite obvious which chapter this is from. This is from the chapter haloalkanes and haloarenes, right? Organic chemistry is is my favorite. So this is basically from the nature of the CX bond. Let's just go over it in brief. Basically, the carbon and halogen atom, this bond that's present, has a dipole moment because of the difference in electronegativity. Carbon is less electronegative than compared to our halogen atom. Now, because of that, you have a electronegativity and you have a dipole moment happening because of that, because of the difference in electronegativities. Now, from this table, it's quite obvious what the answer is. It is CH3. Cl with a dipole moment of 1.860. Now you might be thinking, if fluorine is more electronegative, so obviously it has to have the highest dipole, but that's not the case, because the size of the fluorine atom is smaller than that of the chlorine atom. Now, because of this difference in the size between fluorine and chlorine, you have a difference in the dipole moment. Dipole moment is basically a product of the charge and the bond length. So if you notice, the bond length for CH3Cl is larger, right, compared to that of CH3F. And because of that, and because of the higher electronegativity, or relatively high electronegativity of chlorine compared to the ones below it, you have the higher dipole moment for CH3Cl. Okay, we're comparing bond length to the atomic size to chlorine, and electronegativity of chlorine and the different elements in the group. So the answer to this question is going to be CH3Cl, and I hope that makes sense. Let me know if you have any difficulty. Okay, now the next question given to us is a match the following. Now, from the question and the options that are given, which chapter do you think this is from? If you said D and F block elements, you were right. So this question is basically related to the chapter D and F block elements. Now, the option... and the thing is, I found the answer to this question in the electronic configuration and radii of lanthanoids and actinoids. So it's all given here. So the first question is, actinoid having the configuration read on 5F761-7s2, that is cerium, with the curium with the atomic number of 96. Now this is CM, and it's a direct it's a direct question almost. Lanthanoid having 4F14 electronic configuration in the +3 oxidation state. The answer to this is lutetium. If you see it here, you have the 4F in the +3 Ln+3 state. It has just 4F14. So this is just this, and then the lanthanoid showing +4 oxidation state is obviously going to be cerium, and you have the lanthanoids with the different oxidation states given in this table, and this is actually given in the beginning of lanthanoids and actinoids. So the answer to this question is option A. Now the next one is, we need to study the graph that's given. It's a very fancy graph actually. And this is talking about bromoalkanes. So this is obviously from the chapter haloalkanes and haloarenes. Now, basically what we've been given is these 4 options, right? We have bromomethane, bromobutane, 2 bromobutane, 1 bromobutane, and 2 bromo-3-methyl propane. Now, basically all of these are actually given to you in your textbook. So these options are actually given. Right? This is the thing that's given in your textbook. That's what I copied and pasted over here. So first of all, haloalkanes and haloarenes have a higher boiling point because of the intermolecular forces of attraction. They have a dipole-dipole moment and van der Waals forces. And the attraction becomes stronger when the molecules get bigger in size. So obviously the one with the least amount of, or the smallest boiling point is obviously going to be bromomethane. So this is going to be bromomethane. So I'm just going to write or I should have written CH3Br. Anyways, CH3Br. So that's bromomethane. So that's going to have the lowest. And the next one we need to know, the next thing we need to remember is, as you have when there is an increase in branching, what happens is the boiling point becomes lower when there is more branching. Essentially, what I'm trying to say is that as more is the branching, less is the boiling point. So the next one is going to be 346, and the values are actually given here. So 346, which is 2 bromo, 2 methyl propane. Okay, and then you have this CH3, CH2, CH3, which is 2 bromo butane. So it's in the second position, 2-bromobutane, and then you have 1-bromobutane. So 1-bromobutane is going to have the highest boiling point, and then the low after that it's going to be 2-bromobutane, and then it's the 2-bromo-2-methyl propane, and then you have bromomethane. So the answer to this question is going to be option number D with bromomethane. Then you have 2-bromo-2-methyl propane, then 2-bromobutane, and 1-bromobutane. That's the highest. So the question for visually challenged learners is just which haloalkane has the highest boiling point, and the highest boiling point belongs to 1-bromobutane, which is option D. Okay, now the next question over here is question number 5. The initial concentration of R in the reaction Rp is 4.62 into 10 to the power minus 2 moles per liter. What is the half-life for the reaction K and they've given us the value of K. Now basically this is from the chapter chemical kinetics. Now the thing you need to know, I keep making this mistake. The thing you need to know is the value of first of all, okay, you basically need to know this table. That's what I was trying to say. So basically, if you notice, the value of K over here is in moles per liter per second, and that is for a zero order reaction. So this reaction is a zero order reaction. For a zero order reaction, the value of T half, which is what they're asking us, is going to be equal to R naught by 2K. That is the initial concentration by 2K. So what we're going to do is T half is equal to initial concentration, so 4.62 into 10 to the power 2 moles per liter divided by 2 into 2.31 into 10 to the power minus 2. Oh, I'm sorry, there's a minus 2 here. And we know the units over here, moles per liter per second. Now, obviously, moles per liter gets cancelled. Second goes to the numerator. So this is the right equation. Always double check your units. Your units are a very good indicator of if you are in the right, or if you've used the right formula, stuff like that. Definitely use the units. I wish someone told me this when I was in grade 12. So T half, so you basically can cancel 10 to the power minus 2, 10 to the power minus 2. Then 2.31 is basically, or 4.62 is 2 times 2.31, so 2. And then so 2 and 2 gets cancelled, so you're just left with 1 second. So the answer to this question is option number C, which is 1 second. And so this is related to the chapter chemical kinetics, and that's what is given in your in the solutions part of the marking scheme. The sixth question. When CH6H5COOCOCH3 is treated with H2O, the product obtained is. First of all, if you've noticed the options and even like the question given to you, it's basically it's an anhydride, right? It's an acid anhydride. Now, this is from the chapter aldehydes, ketones, and carboxylic acids. So this is actually a preparation method of acids from acyl halides and anhydrides. Oh my goodness. Okay, acyl halides and anhydrides. So benzoic ethanoic anhydride. Actually, this was a acid anhydride, but basically benzoic ethanoic anhydride, when it undergoes a reaction with water, it gives us benzoic acid and ethanoic acid. So this reaction is actually given in your textbook. So just mark that off, right? The next question, the seventh one. Formulation of cobalt 2 chloride ammonia complexes, and actually this is from the chapter, if you notice, cobalt 2, that is from the chapter coordination compounds or coordinate chemistry. I found this chapter so difficult, and I don't know why. Even in my master's, I found this chapter difficult, so I don't know why. So basically, it's just the table that's been given to you in your textbook. So you have yellow, 1:3. So that's Y is 1:3, and X is going to be, it's the green one. So that's COCH2 NH3 4 plus Cl minus. So we're, oh no, oh no. Um, I'm just gonna say that. Okay, so the answer to this question is going to be obviously option number B. And this is based on the table given to you in your textbooks. Okay, the next question. Which of the following contains only beta glucose as its monosaccharide unit? Now, this is from the chapter Biomolecules. And basically, cellulose is the one which is only composed of beta glucose units. The remaining are not, and I just chose to include the cellulose. Okay, the next one is question number 9. Which of the I should just, okay, yeah, it also gives you here starch contains only alpha glucose, sucrose contains alpha D glucose, and beta D fructose. Glucose and maltose contains alpha D glucose, and cellulose is the only polymer which has beta D glucoside. Next question, question number 9. Which of the following sets correctly represents the increase in paramagnetic property of the ions? Now, this is from the chapter D and F block elements, if you notice. So this is basically related to the chapter D and F block, and this is related to the magnetic moments. And this is actually, again, given in your textbook. So we're talking specifically about 4 of them, which is the ones that we care about for this question is titanium, Ti3 plus, the titanium ion, and then you have Fe2 plus, Cr3 plus, and you have Mn2 plus, right? Now we need to figure out the order of the paramagnetic property. Now, basically, if you notice, there is a difference in the number of unpaired electrons between all of these. So, the number of unpaired electrons for Ti3 plus is 1. Number of unpaired electrons for Fe2 plus is 4. And then you have 3 electrons for Cr3 plus and 5 electrons for Mn2 plus. More is the number of unpaired electrons, more is, or that is what determines the paramagnetic property, right? So the paramagnetism depends on the number of unpaired electrons. So Ti3 plus has the lowest. So out of all of these options, A, B and D have the Ti3 plus is the lowest. Then you have Cr3 plus, which is option number D, and then you have Fe and then Mn. So more is the number of unpaired electrons, more is the paramagnetic property going to be. Based on that, we just answer this question. Okay. The next question. The first order reaction is found to have a rate constant K equals to 5.5 into 10 to the power minus 1 minus 14 seconds inverse. So the time taken to completion of the reaction, actually it never undergoes completion. Now this is because the rate of the reaction is directly proportional to the concentration. Because it is directly proportional to the concentration, as you have a decrease in the concentration of reactant, the rate of the reaction will also start to slow down. Okay, so no matter what, when you start slowing down, so what happens is there comes a point where the amount of reactant is so small that the rate is also going to be significantly small. So because of this, the reaction is never going to undergo completion. So we don't have to math this, we just need to know the logic for this question. And this is obviously from the chapter Chemical Kinetics. Next question. A student was preparing aniline in the lab. She took a compound X and reduced it in the presence of nickel as a catalyst. What would be the compound X? Basically, what we're talking about is a reduction reaction, right? Reduction reaction to form aniline. So what will undergo reduction to give us aniline? If you said nitrobenzene, you are right. Basically, this reaction is actually given to you in your textbook. Here you have NO2 and it undergoes reduction in the presence of hydrogen and palladium and ethanol, right? But basically, it's the same concept. You have reduction taking place. You have nickel as a catalyst. So it's a different catalyst, but basically you have nitrobenzene undergoing this reduction reaction. So the answer to this question is going to be nitrobenzene. Which of the following compounds give us a oxime? And this is from the chapter amines. It's actually the preparation of amines. Okay. reduction of nitro compounds. The next question over here we have is, which of the following compounds gives an oxime with hydroxylamine? So oximes are formed when aldehydes or ketones react with OH, or they don't react just with OH, but this that react with hydroxylamine to give us oxide. And this is true for aldehydes and ketones. Out of the options that are given to us, CH3COCH3 is a ketone, right? You have CH3COOH, ethanoic acid, which is an acid. You have CH3COOC. Okay, this I will write it out for you. CH3COO. I'm pretty sure I've written it. No. Hang on. No. Sorry. Sorry. COCH3. So this is an acetic anhydride, and this is an acyl chloride. So out of all of these options, only option A is a ketone which undergoes a reaction with hydroxylamine to form oxide. And this is under the first, it's actually one of the first set of reactions that you learn in the chemical reactions of aldehydes, ketones, and carboxylic acids. I think it's a nucleophilic substitution, addition reactions. Okay. So that is the answer. Your answer to this question is going to be option A. The next question you have over here is an assertion and a reasoning question. So out of for assertion and reasoning questions, you have both A and R are true. R is the correct explanation of A. Both A and R are true, but R is not the correct explanation of A. A is true, R is false. A is false, R is true. Honestly, these sort of questions used to confuse me in the past. Sometimes it does even now, but it's okay. So the question over here is, they've given us a complex. It has a magnetic moment of 2 unpaired electrons, while this complex has a paramagnetic moment of 4 unpaired electrons. And the reason is because of the inner orbital complex, and the other one is an outer orbital complex. So this is from the chapter coordinate chemistry. So this is from the topic magnetic properties of coordinate compounds, and this is actually an example which is discussed over here. So according to this, you have a species containing so you have it here. So it gives you the whole thing, right? And the reason is this is apparent anomaly explained by valence bond theory, and this is under the concept of valence bond theory. So based on this, both A and R are true, and R is the correct explanation of A. And if you want me to clarify or explain a question in detail, definitely let me know. I will be more than happy to do so. This is just me trying to, speed up and make sure your time is also saved. So we've next been given question number 14. It's also an assertion and reasoning question. For strong electrolytes, there is a slow increase in molar conductivity with the dilution and can be represented by this particular equation. The value of A, the constant A for NaCl, CaCl2, MgSO4 in a given solvent at a given temperature is different. So first of all, based on looking at the word electrolytes and conductivity, we can assume safely that this is from the chapter electrochemistry. Now this particular sentence is given word to word in your textbook. You'll be surprised at the number of things I found in the textbooks. I wish I knew, but you know what? When you're stressed about learning maths, physics, and chemistry at the same time, I feel like it becomes a little more complicated. As an adult, I quite enjoy solving these papers. So we've been given the exact same sentence. However, if you notice, the equation is incorrect. So obviously A is going to be false. However, the value of the constant A for NaCl, sodium chloride, CaCl2, MgSO4, all of that is given, is also this, again, the same sentence is mentioned over here. So the value is dependent for a specific temperature. It actually is dependent on the nature of the electrolyte or the type of the electrolyte, and because of that, the values are going to be different. So for this, we would pick A is obviously false, and we're also going to say, but R is true. This because we're not going to talk about, you could say R is not, R is true, A is false. We know that for a fact. Okay. Now the next question over here is question number 15. Glucose does not form a hydrogen sulfide addition product with NaHSO3. Reason it exists in a 6-membered cyclic structure called pyranose structure. Now my initial instinct when I saw this question was that obviously A is right and R is also right, and R is the right explanation for A. However, that is not the case. So this is based on the cyclic structure of glucose. So in the cyclic structure, you have, despite aldehyde group, glucose does not give a Schiff's test. It does not, and it does not form the hydrogen sulfide addition product with NaHSO3. So obviously, it does not do that. But you need to, for the reason itself, it needs to say that it does not have a free aldehyde group, right? The free aldehyde group explains the fact that it does not undergo this reaction. Okay, it existing as a 6-membered chain is true. However, that is not, it is an implied reason, right? So you need to have it mentioned clearly, and because of that, option both A and R are true, but R is not the correct explanation of A. Now, if it had told that glucose exists in a 6-membered cyclic structure called pyranose structure, which does not have a free CHO or an aldehyde group, then you would have been able to pick option A. You have to do option B because it is not the right explanation, because it does not mention the presence or the absence of a free aldehydic group. Okay, so that's from the chapter Biomolecules. And this is the last question for this video. You have the half-life for a zero-order reaction is independent of the initial concentration of the reactant. For a zero-order reaction, rate is equal to K. I keep doing this. All right. For a zero-order reaction, we know that it is independent to the initial concentration. That is definitely not the case. It's right here. So that's A is obviously false. For a zero-order reaction, rate is equal to K. That is true, and because of that, A is false, but R is true. So option D is the right answer. With that, we're done with section A for the sample question paper of 2024-2025. I know you're super close to your board exams. You're probably already starting to prepare for the pre-boards. Definitely let me know if there is a specific concept you find difficult. I would be more than happy to help. Also, if you have any suggestions related to this particular concept or this particular video type, definitely let me know. If you want me to give you more information, if you want me to get less information, either or, I thought best to have the textbook on the side because that helps you see visually where you can find these answers in your textbook. And you'd be surprised at the number of times I've found the answer in your textbook, or even if it is related to a particular question given in the back, like the exercise questions. So all of those are really important, and I wish you all the best. And in the next video, we are obviously going to go on to learn about section B. And I'm going to try and post all of these videos within within the same week, and I hope it's of help to you.